In this video we're going to look at how we can find the highest common factor of two numbers. And the particular example we're going to look at is finding the highest common factor of 24 and 20. These are the steps that we're going to use. So step number one is find the prime factors of each number. And to find the prime factors we use the prime factor tree. And I'm assuming that you're familiar with this. So I find any two numbers that multiply to give me 24. So I'll choose 2 and 12. I notice that 2 is a prime number, so I stop here. But I have to carry on with this leg. Two numbers that multiply to give me 12 are 2 times 6. I notice this is a prime number, so I circle it and stop there. And two numbers that give me 6 are 2 times 3, and these are both prime numbers. So I circle both, and that's the prime factor tree finished. So I'll write these out. In order of size, it just so happens that that's already the case here. Now I'll do the same, and I'm finding the prime factors of 20. I'm going to be a little bit awkward just to prove to you that the particular numbers you choose in the order doesn't really matter, so I'm going to choose 5 times 4. I notice this is a prime number, so I can circle this, and 4 is 2 times 2, and here we have we circle them because 2 is a prime number, and again we finished. So now I'll write them in order of size, so 2 times 2 times 5, and we're done. So that's step one completed. We found the prime factors of each number. What we're going to do now is enter the prime factors into a Venn diagram. And so you need to be a little bit familiar with how a Venn diagram works. But in this circle or closed curve, we're going to put all the prime factors of 20. And in this circle or closed curve, we're going to put all the prime factors of 24. But the important area is this intersection. And any prime factors that are common to both 20 and 24 go in here. So we look at our list and we see, look out for the prime factors that are common to both. And this is how to do it. I can see I have a pair of 2's here and another pair of 2's. But I can't pair anything else off. There's nothing else that can be paired. Now, having identified your pairs, you write it in the intersection, but only once. So with this pair, I only put a single 2 in. And with this pair, again, I only put a single 2 in. That's a very important point. And so now if we look at 20, we've got 5 remaining. And if I look at 24, I've got a 2 and a 3 remaining. Now it's very important to check because it's easy to make mistakes, but as long as you check, then you can see if you've made a mistake and correct it. So when I look at 20, in the closed curve or the circle, I'm expecting to see 2, 2 and 5. And indeed, when I look at this circle, I can see I've got the 2, 2 and the 5. And similarly, when I look at 24, I'm expecting to see 2, 2, 2, 3. And again, if I look at this circle, I've got 2, 2, 2, 3. If you'd made a mistake with these common factors and accidentally, for instance, put too many in the middle, you'd soon realize that there's a problem because you'd have far too many prime factors for 24. Step 3, we multiply all the numbers that are in the area of intersection. So this is the area of intersection. I'm going to multiply these two numbers together and I get the answer 4. And so the highest common factor of 24 and 20 is 4.